Hey, it's Mr. Maz here. I woke up this morning and my daughters were yelling that it snowed outside. And I looked out the window and sure enough it did. Just a couple days from Easter, we got the flowers blooming on the bushes and there's snow covering the ground. Kind of crazy. But then it got me thinking about, the most wonderful time of the year, Christmas, which got me thinking about decorating my house. Now, decorating a house is all about exterior illumination. That's right, lights. Now, I'm not going Clark Griswold style, but I am looking for something simple, and we have this wonderful thing called math. Check this out. Boom. Just like that, we got a graph over my house. So what I'm looking to do is very simple here. Just follow the lines of the roof. Something like this. So really what I need to do is figure out what is the linear length of all of these line segments here to figure out how many lights I would have to get to accomplish this. Now, to make the math a little bit easier to see, we're going to go ahead and get rid of the house so we can see just the lines that we're dealing with. And we should very easily be able to make the calculations. And if you haven't figured it out yet, to figure out the diagonal lines, we are absolutely going to be using the Pythagorean Theorem. So I've got a simplified version here so it's easier to see what we're doing. Now let's go ahead and start with the simple part, like this horizontal line right here. It's really just counting or using subtraction. So we're right on the x-axis. We notice that we're starting at 17 and going to 30. So 30 minus 17, that's got a length of 13 so far. All right, now the diagonal or the oblique lines are going to be a little bit more complex, but obviously nothing we can't handle here. We've done this before. So let's go ahead and start with this side right here. All right, so that side, if we look right here, that is our right triangle. So we can go ahead and count what our legs are and use that to identify our hypotenuse with the Pythagorean theorem. So if we're going vertically here, we're going up to 5. So that leg is 5. And the horizontal leg goes out to 9. So we're looking at 5 and 9 as our legs here. So we're simply going to do 5 squared plus 9 squared. We'll go ahead and put a C up here for the hypotenuse. Further simplifying our squares, we've got 25 plus 81 gives us 106. And hopefully at this point everybody knows the inverse of taking the square of C is to take the square root. And the square root of 106 is going to be approximately 10.3. Can't see that down there on the screen, so let me put it right over here. Approximately 10.3. All right, so I'm going to label this up here. We've got 10.3 for that. Now, let's go ahead and look at another diagonal point. Going to remember if that's 10.3. Let's go ahead and look at this whole side. All right, instead of splitting up into two separate pieces, we'll go ahead and consider that as the hypotenuse for this right triangle here. We already know that this part is 5, and now we're going from 9 to 17, so that other leg is 8. So we're going to use a Pythagorean theorem again. 5 squared plus 8 squared. We'll put the C up here this time, equals C squared as our hypotenuse. So we've got 25 plus 64, which is going to be 89 in this case. And once again, we need to take the square root of that. So the square root of 89 is approximately 9.4. So right up here, we've got 9.4. So 10.3 and 9.4. Can't forget this part over here was 13. And we got one part left. This little diagonal part here, we've got a leg of 3. And going from 7 to 12, that's a leg of 5. So let's go 3 squared plus 5 squared Got our new hypotenuse over here now. 9 plus 25 gives us 34. Once again, not quite a perfect square, so we're going to end up with an irrational number. So C is going to end up being about 5.8 in this case here. All right, now to find the total length of what we're looking at here, we obviously are looking at all of the lengths that we just found: 10.3, 9.4, 5.8, and 13. So we want to find the total of all those. So we're going to add all those up. So we're looking at 10.3 plus 5.8 plus 9.4 plus 13 altogether is going to be 38.5. One quick thing I want to throw in here. On the graph, my house was 30 units long, but it actually is 45 feet long. So I want to just show how we're going to change that 38.5 units to how many feet that we have here. So it's literally just setting up a quick proportion. So we're going to cross multiply. We're going to take 30 times x and 45 times 38.5. So we get 1,732.5 and divide that by 30. And this will tell me how many feet of lights I would have to get. So I would have to get 57.75 feet of lights. I would probably round that up to 60 because I doubt I can buy 57.75 feet of lights. The next type of problem we're going to look at is finding the perimeter of a figure on a coordinate plane. Perimeter, remember, is the length around the outside of a figure. So we're looking at going around the outside of this particular quadrilateral. Now 3 of the 4 sides are very straightforward. We're just counting horizontally. This side is 3. This side is also 3. And then down on the bottom, we're counting 7. And a quick way to do that, the points are lined up on the x coordinates of 2 and 9, so just 9 minus 2 is 7. Now, the oblique side, once again, we're looking at a Pythagorean Theorem problem here. So here's our right angle. Our one leg is 3. Our bottom leg, not 7. That's the side of the trapezoid down there, but the side of the triangle is 4. So we are looking at 3 squared plus 4 squared equals c squared. So we've got 9 plus 16, and this is going to be a nice perfect square here. The square root of 25 is 5. So our c is 5, but don't forget, we're looking at the perimeter here, not just that side. So we're looking at 3 plus 3 plus 7 plus 5. So we're looking at a total perimeter of 18. The last type of problem we're going to look at is they're going to give us some vertices, and then we have to find the lengths of the sides and put them in order from least to greatest. So we're looking at triangle. The first triangle ABC, the first vertex is A at 4, 5. So it'll be right about there. B is negative 2, 3. So from the origin we go to the left 2 and up 3, right there. And C is 2, negative 2. So we go to the right 2 from the origin and down 2 right to there. And once again, we're looking at using the Pythagorean theorem here to figure out what these side lengths are going to be. So let's look at going from A to B here real quick. And I want to show a couple different things here. From A to B, we can look at just the vertices. We don't actually have to look at the actual graph and count them. If you look at the x-coordinates, we have from 4 to -2, that's 6. And if we look at the y-coordinates, between 5 and 3, that's 2. So those are our legs. We can use 6 and 2 as our legs here. So AB, I'm looking at 6 squared plus 2 squared equals c squared. So we have 36 plus 4, which is 40. So C is going to be, or the length of AB, I should say, the length of AB is going to be the square root of 40. Now, since all of these are going to be in square root form, we can just leave them as a square root of 40. We don't have to find the decimal approximation. The square root of 40 is exact, and then we can compare all of those radicals in the end. So I'm going to put AB is the square root of 40 up here, just to kind of keep a record of it. Erase everything down here so we can move on to the next one. So let's go to, let's try BC now. So using the same concept, BC, if I look at the x-coordinates, I'm looking at -2 to 2. So those are 4 apart. And I look at the y's, all right, so right here are my y's, from 3 to -2, that's 5 apart. So the legs that we're going to use are 4 and 5. So I'm looking at 4 squared plus 5 squared equals a hypotenuse. So I've got 16 plus 25 when we square 4 and 5 respectively. And that gives us 41. And that equals c squared. So to figure out what c is, we're looking at the square root of 41. So BC is exactly the square root of 41. It's just a little bit longer than what AB is. And then finally, we have AC. For AC, I'm actually going to go ahead and draw right on the graph here. So I transferred it over. So remember, 4, 5 is A, B was -2, 3, and this was C. So I'm going to show you how we can do this on the graph like we've been doing it as well. We don't have to just use the coordinates. So this is our right triangle here, and we can very easily see that this is 2. And then we can kind of count down 1, 2, 3, 4, 5, 6, 7. That side is 7. And that should match up with AC as well. Because if I'm looking at the points from AC, the A, or the X coordinates, 2 and 4, those are 2 apart. And the Y coordinates, 5 and -2, they're 7 apart. So we can do it either way, looking at the graph or using the coordinates. So we're looking at 2 squared plus 7 squared is going to be our hypotenuse. So we've got 4 plus 49 in this case, and 4 plus 49 is 53. So we take the square root of that to find C. So that one, that is our largest side because 53 is larger than 41 or 40. So the square root of 53 is larger than the square root of 41 and the square root of 40. So the answer to these sides from least to greatest, AC is the biggest, and then BC is the next largest side, and then AB. So we haven't had a study island assignment yet since the remote learning began, so it's about time for that. So after you watch this video, your first assignment for this week of April 13th is going to be called Distance on Study Island. So make sure that you complete that. And as always, you're going to have unlimited opportunities to improve your grade. But please make sure that you're getting this done Monday or Tuesday because you will have another assignment for Thursday and Friday. Good luck, and if you have any questions, jump into my Zoom sessions, or you can always email me.